So welcome everyone. Thanks so much for attending this morning. We really do appreciate you guys taking the time to join us today. Looks like we've got a good crowd, so that's awesome. My name is Jaime Niswonger. Obviously, I work for Keyhole Software. And today's topic, as it says on the slide, is continuous delivery. Hopefully that's what you signed up for, right? So we're going to attack this from a couple different angles today. First, we're going to talk about the theory, go through some slides, look at some definitions, challenges we face, etc. And then we'll follow that up with a demo, kind of a real-time continuous delivery demo. So kind of a words up front, followed by actions at the end. So before we jump in, I got a caveat. And the caveat is, this topic can be a bit of a religious struggle sometimes, I think. I think anytime when we're talking about methodology, there can be a fair amount of bigotry involved, meaning that people dig in on their beliefs, right? They claim their way or a specific way is the best and only way to do things. That's not what I'm going to do today, okay? That's not how we're going to proceed. So we're going to talk about continuous delivery, but the goal is not to convince you of anything, right? We're going to talk about what it is, why we might use it, what are some benefits, but there are really many factors that drive methodology choices, right? In my opinion, it's rarely as clear-cut as, cut and dried as people would have you believe sometimes. So goal is talk about the concepts, and then you guys decide if there are benefits or things to pursue in this space for you. Bottom line kind of is that outcome matters more than methodology, meaning don't get hung up on hard and fast rules. If your team's highly effective, you're delivering well, you're doing the right things, your customers are happy, then you're probably doing good stuff, right? So look for areas to improve, but so on. With that, let's dig in. Going to start with a profound statement. Software development is hard. I've heard it said, and I think I agree, that programming is easy, but software development is hard, okay? And there is a difference. What I mean by programming is writing code, right? We write code to do something. Whereas software development is really beyond that, right? It goes into deeper concerns like collaboration and communication with other teams, testing and validation of our software, information security, deployments, monitoring, maintenance, right? The list goes on in the things we have to worry about in the software development space. And doing those things is hard. I know it is because we talk incessantly about how hard it is, right? And we spend a lot of time trying to make things easier to do, developing new patterns, new approaches, new methodologies, and so on. Now, with that said, strangely enough, I think even though we know it's hard, we sometimes seem shocked when it turns out poorly, right? It's a paradox, I think. I think on one hand, we know it's hard. On the other hand, we expect it to turn out well just regardless, right? Even though we're maybe repeating the same process that didn't go that well the last time we did it, right? I think, and one example I always use, and I think the classic example of this is what production deployments look like in many organizations, right? And maybe some of you can relate to this, where deployments become events, right? Where we have special ceremonies, deployment plans, some special hour of the night we're going to do this, 11 p.m. on a Saturday night, right? We got a team standing by like sentry outside the Capitol building just in case something goes wrong. And we tell our management, though, I expect it's going to go smoothly. But honestly, if we expected it to go that well, we wouldn't do it that way, right? It would be a non-event. So anyway, my point is software development's hard, and that's the reason to talk about continuous delivery. I'm going to guess that if we were in a room together, which we're obviously not, but if I were to ask you to raise your hand, if you think you're doing continuous integration and continuous delivery on your current projects. Okay, I bet a bunch, if not most of you, would raise your hand. After all, we all have automated pipelines, right? And what do we call those things? We call them CI/CD pipelines almost universally, right? Continuous integration, continuous delivery pipelines. But the question is, are you really doing continuous delivery? I know personally, I thought for years I was, only to realize later that I really wasn't close, okay? So I want to look at a definition of what continuous delivery is, just so we kind of level set. There's a lot of different ways to describe it. Different people have different feelings, so let's just resolve this down to what we're talking about today. And clearly the best source of any definition in this day and time is Wikipedia, right? So that's where we're going to go. So if you look at the Wikipedia definition, it says continuous delivery, or CD, is a software engineering approach in which teams produce software in short cycles. They ensure that their software can be reliably released at any time. And when releasing the software without doing so manually, it aims at building, testing, and releasing software with greater speed and frequency. Okay. This approach helps reduce the cost, time, and risk of delivering changes by allowing for more incremental updates to applications in production. A straightforward and repeatable deployment process is important for continuous delivery. Okay. So that's a lot of words. The thing I like about this definition, though, is it breaks what continuous delivery is down into really two categories. Okay, it's talking about the characteristics of continuous delivery. What does it look like? And then it talks about the benefits of the goals. Why would I do it? Okay, if we remove the fluff here and we just look at the characteristics, it's really talking about short developments or small development cycles, right? Keeping our code in a state that where we could release it at any time. And it's talking about automation, right? Not doing things manually, but automating them. If we look at benefits and goals out of that same description or same definition, it's talking about increasing speed, improving accuracy, reducing risk and time and cost. Implicitly, it's really describing how we get features to users faster, right? So with that, let's dig a little deeper into why we want to do continuous. So why continuous delivery? The first reason why is really around cycle time, to reduce cycle time. Now, cycle time, for those that maybe aren't completely familiar with that term, really, I think is borrowed from the manufacturing sector, if I'm right. Okay, I think in its simplest definition, it's measuring how long it takes to go from a beginning or the start of a task to the finish, okay? And in software development terms, it really is how long does it take to go from a requirement or a feature request to deployment of that feature or giving that feature to an end user to use. I contend this is probably the most important metric we should think about as software developers, okay? It's not lines of code. It's not percentage of those lines that we cover by automated tests. It's not our velocity, our burn down, or how many points we knocked off the Agile board this sprint, how many defects we have, or how fast our pipelines run, right? All of those metrics have a place in our process, in our software development process. But the bottom line really is how long it takes us to get the user what they need, okay? If we want to be better, faster is better, right? If we can maintain quality. So reducing cycle time, number one reason why we would think about continuous delivery. Second is reducing risk. To me, honestly, when I first thought about this, that seemed counterintuitive, right? My thought process was, if I'm having trouble at my current cadence, right, then why is going faster or why is doing this more often going to reduce my risk? The principle is, though, that if it hurts, do it more often. Okay, if it hurts, do it more often. Not because you like the pain, but the implication is that if you do it more often, by the very nature of having less time passing, we will be integrating and deploying less code. Okay, so the simple question is it easier to integrate less code or more code? Obviously, less code is easier to deal with, right? I think the issues we experience with code integration are most often a result of too much complexity, too much code coming in at once, right? So if we're releasing once a month, we're going to have once a month's worth of code from all our developers to integrate and deploy, right? If I do that more often, then I have less code to think about and worry about, right? So secondarily, I think related to this is by integrating and deploying more often, it's going to force you to improve, to look for ways to make it a non-event, right? We talked about our deployments being events. We want it to be a non-event, right? So if it's difficult once a month, but I go to once a week or once a day or even more often, I'm not going to be willing to put up with the status quo of the pain it takes me to deploy, right? It's going to force me to improve my process. Okay, so number one reason, reducing cycle time. Second reason we talk about is reducing risk, right? Doing things more often will reduce our risk. Last point then on this slide is user feedback. I think one of the most common issues that we see with software development is the user not getting what they want, or more importantly, maybe what they need, right? So by deploying small incremental features, you benefit by faster feedback loops, right? You're getting feedback faster. Faster feedback loops lead to less rework, right? If I've deployed a month's worth of things and the user hates it, I've got a month's worth of things to redo, right? So if I can break this down into smaller increments, get faster feedback loops, I'm going to lead to less rework. Less rework leads to happier customers and ultimately to happier developers, right, like us. So reducing cycle time, reducing risk, user feedback. As we go on here, I'm going to grab a drink first. So let's talk some specifics about what continuous delivery really looks like, okay? First point is that the main branch is always releasable. Okay, this doesn't mean that we will release it, but it's really speaking to the expected quality of code we want to maintain in that branch, okay? It could be released at any time, and therefore we have to treat it like it will be, right? So main branch is always releasable. Developers then, second bullet, commit their code to the main branch at least once per day. Now, is there something magical about once per day? No, obviously not, right? But again, the principle here is working in smaller cycles, not introducing so much change at once to be integrated. Establishing a daily cadence changes the way we work, right? It changes the way we think about writing code. It has to, right? By default, it's going to have to change the way we think and work. And then the last point is really about automation, right? Build, test, and deployment of the main branch are automated. Now, the caveat here is notice this doesn't say deploying to production. It's talking about automation and deployment, but it doesn't say deploy to production, right? There is a difference between continuous delivery and continuous deployment, okay? The latter meaning that a production deployment is a part of the automated process. So continuous deployment is talking about automated production releases based on commits and our process landing in our main branch, okay? But continuous delivery is really just talking about automating deployment to some environment, and there's value in that, okay? Pulling off continuous deployment obviously requires a lot more maturity, but it is a logical extension to continuous delivery. So now, all of these things, in my opinion, change the way, as I said, the way we think about writing code, changes the way we think about integrating that code, it changes the way we approach testing. It really forces us to think about the implication of each commit that we make on a deeper level, right? And really, to me, this is the key with continuous delivery. This is where the value lies in continuous delivery, in my opinion, okay? It changes the way we approach it and gives us a reduced risk and more reliable integration. As we look at this list, there's a common word in each bullet, right? And that common word is main, right? The main branch is what we're going to release. Developers are committing to the main branch at least once per day. Build, test, and deployment of the main branch are automated, right? It's talking about the main. What this is implicitly saying is if we're going to continuously deliver, we can't be isolating code by creating long-lived feature branches, okay? Or in other words, we should or maybe can be or should be using trunk-based deployment or development. So let's talk about trunk-based development real quick. I'm guessing not all of you are familiar with this idea of trunk-based development. If not, I think the name is probably pretty self-explanatory, but let's give it a definition anyway. Okay, according to trunkbaseddevelopment.com, right off their homepage, trunk-based development is a source control branching model where developers collaborate on code in a single branch called trunk or main. I think I added main in parentheses. Now, pause here. Name's probably not that important, whether we call it trunk, whether we call it main, whether we call it Jamie, whether we call it Martha, right? Doesn't really matter. That's not the point. The point is we've got a single branch, right? So in that single branch, then, we want to resist any pressure to create other long-lived development branches by employing documented techniques. They therefore avoid merge hell, nice, do not break the build, and they say we live happily ever after. I'm not sure about the last part, how we can prove that, but that's what they say. Okay. So we can really sum this up in a few words. I think, again, it's a lot of words, but when I look at it, what I see is resist long-lived development branches, okay? Creating long-lived branches of code like this, and what I mean by that is delaying code merges for weeks or days into the main branch will cause problems. I think we've all experienced these, right? Most of us probably have. The slide talks about merge issues, or what they call merge hell, when we're bringing multiple streams back together, right? After weeks of development have gone by. It's not a fun experience, right? Usually we can't get volunteers to do that. I've actually been at companies where we've had a specific team or a person whose sole responsibility is merging code branches back, right? Not a great job. Kind of related to that then is this idea of rework, right? When we have these merge issues, we often end up with rework when branches don't play together anymore, right? When they don't play nicely together, one or sometimes both of those branches have to be reworked, causing us delays. And then similar, as it talks about on the definition there, broken builds, right? Generally leading to these challenging triage exercises where we have to spend a bunch of time trying to figure out what's gone wrong with our builds. So bottom line is this: continuous means continuous, all right? It's not called occasional integration. It's not called occasional delivery. We must be continuously integrating code. And one effective way to do this is to adopt a trunk-based development approach, okay? Opinion. Saying that, though, I'm not trying to imply that this is a trivial shift, okay? It's not a trivial shift. If you're used to doing feature branching, then it's going to be a significant mind and process shift probably from what you're doing. It will change the way we think as developers, the way we have to work together as a team, and most likely it's not going to go that well at first, right? This is an experience thing, right? We've got to establish process, get some experience, and refine that, just like every other methodology change we ever make, right? One thing about this, when I actually thought about trunk-based development the first time, was my initial question to this idea was, well, if I marry this up with continuous delivery, saying that I got to commit to the main branch every day, what do I do when I'm not done with my work, right? What if my feature isn't complete yet? Do I get some kind of free pass for that day, right? Is there an exception to the commit once per day rule? The short answer, no. Okay, so that's going to lead us into the next slide, which is really a discussion of feature flags, or what some people call feature toggles, okay? I'm going to touch on this conceptually, but really I can't go too deeply into this. There's a lot of facets to feature flags, okay? Incidentally, I should mention that we do have a blog landing in the next few weeks on this topic. So if you're interested in a more in-depth discussion or expose on feature flags, I encourage you to follow our blog and pick that up. And interestingly enough, it's another Niswonger who's producing that. So that's kind of funny. But not me, not me. But for the sake of this discussion, what I want to talk about is feature flags being an essential piece of trunk-based development again. Okay, so what we're saying is we're going to commit once a day to our main branch. We're also saying I may not have code finished that I can commit, right? So that's where feature flags come in, essentially giving us a strategy for isolating commits on incomplete features, okay? Using them avoids long-lived feature branches. Essentially, it's just flipping the problem on its head, right? Okay, so rather than creating branches at the Git or SCM layer and separating our code, we're using feature flags to introduce conditional logic within the code base, okay? Essentially isolating unfinished or unverified code, okay? In their simplest form, they can just be a conditional statement to protect those code paths that are protected or incomplete, okay? But obviously there are other strategies that we could use for implementing them as well. Feature flags are part of a larger movement you might have heard of called progressive delivery, and probably that'll be a topic for a future discussion we'll have. But for now, just know that it's a larger discussion with things like blue-green deployments, canary deployments. Feature flags are a big part of the progressive delivery movement. Essentially a bunch of strategies for extending the continuous delivery space. And the idea is that we're going to reduce risk, right? Now, all of these are powerful ideas, okay? But what does Uncle Ben say? Uncle Ben says, with great power comes great responsibility. So there are some best practices to think of in this space. and ways to get yourself in trouble if you don't follow them, okay? So first one, use a framework or roll your own, okay? The real point here is have a consistent approach, okay? Minimally, you could roll your own feature flag system, right? Use a database, use config files, use environment variables with simple conditional logic or strategy patterns, right? Really, it depends on the complexity of why you want feature flags. Feature flags have use far beyond just this trunk-based development code isolation standpoint, right? So there's a whole, as I said, there's a lot of facets to feature flags. As complexity grows, you can continue to roll your own and deal with that. But there are SaaS-based solutions for feature flags. Vendors like LaunchDarkly, Split.io, Harness, a bunch of others offer extensive kind of feature flag implementations that you can purchase as a SaaS offering. So that's the first one. Use a framework, have a consistent approach, organize your code around feature flags, okay? Second one is default flags to off. Clear principle here is that we don't want to release things. The point we're trying to get to is we don't want to release things in an environment until we're ready, right? So default them to off, and that will keep us from accidentally releasing things into environments we don't want them. Required to be intentionally turned on in each environment, right? So if I add a feature flag, I isolate some code, any deployment of that to any environment should not harm that environment at all until it's intentionally turned on. Next bullet, avoid feature proliferation. Okay, this is really simply saying if I have too many features, my code can be hard to read, right? Too many conditional blocks make code logic hard to follow, right? And this really ties directly to the next bullet of cleaning up obsolete flags, which is really kind of a technical debt issue. But the premise is, at least for sake of this discussion, is we're using these feature flags to isolate code that's not ready yet, or it's incomplete. So once it's complete, we should remove that conditional logic, right? Again, not counting for other reasons to use feature flags, but for this incomplete code protection idea, for sure, we should have the discipline, and it will take discipline to clean up our no longer needed feature flags. It should be built into our planning, right? Last one is don't create dependencies between flags. Each flag should behave independently, right? If I need to turn one off, it shouldn't have any effect on another. That will make it, basically will give us unexpected behavior. So have independently controlled feature flags. How are we doing? All right, last slide. Crazy. How do we pull this off? All right. And then we'll get into a demo here. Well, the first and obvious answer or thing is it's going to take effort, right? But by that, I don't mean just try harder. Okay, the old try harder isn't what I'm saying, but it's giving effort to actually improving, right? It's the proverbial work smarter idea. We also just can't accept the status quo, right? Sometimes we get used to what our pain is and we just deal with it, right? And we think that's normal, but we should look for ways to improve, specifically looking for reducing cycle time, right? That's the best metric to use for are we improving or not. I really think that in many cases, we can start down this path without changing too much at all, right? We can likely even keep our feature branch pull request approach to start with and just kind of see where it goes, okay? And the bullets there say, shorten our feedback loops. These are things to start with. Try to shorten our feedback loops and get things out more quickly and get feedback from our customers. We do that by managing our complexities, right? By breaking work down into smaller, more manageable features. And then improve our automation. Automate everything, our builds, automate our tests, automate our deployments, and those can become building blocks for our process as we move forward. This kind of sounded easy when I just played it back in my head there, but it's really not meant to sound that easy. As I said, it's going to take some effort. It takes some time. And unfortunately, there's really no prescription for this, all right? Every org, every team, every project has different factors at play, right? Experience of the team, size of the team, the available tools we have at our disposal, the technology we're using, budget, policies or regulations, whether those be internal or external policies and regulations, right? But the goal is to reduce cycle time, right? and increase or at least maintain quality while we're doing it. So, as I stated from the beginning, I still believe this, that outcome matters more than methodology, okay? Don't get hung up on hard and fast rules, just look for ways to improve, okay? So I'm going to go ahead and jump into the demo. It looks like we are about 30 minutes in, so we're on track. But if you have questions or things you want to talk about related to the slides, go ahead and dump those in the Q&A, and I promise we will try to get to those. All right, so I want to jump into a demo here. My fear is with this, that this is going to be, that I'm going to lose some of you, okay? And the reason is that automation at this level is hard to pull off, okay? Well, hard to pull off is the wrong word. It's not trivial. It's probably a better way to say it, okay? And when you're doing automation, sometimes the demonstration of the automation is hard to convey because everything's happening behind the scenes, right? So I'm going to talk about the slides and then we're going to jump into it and look at it specifically. But the key here is that, especially in the room, since I can get feedback from you, keep me honest as to what's going on at any given time if you're confused, okay? The demo is this. We're going to have an application, okay? And in our case, it's going to be a TypeScript-based Apollo GraphQL API. Sounds like a lot, but just think of it as an API. If you're not doing GraphQL or you don't know what that is, just think of it as an application that's an API-based application, okay? That application's living in a source repository, Git in our case. We're going to do work on that repository in the main branch, okay? Just like we talked doing trunk-based development. When commits happen on that main branch, we have some pipeline, some automation sitting behind that, right? The commit is going to trigger a Git Action workflow, a GitHub Action workflow that's essentially going to ultimately produce an image. But along the way, it's going to do some testing. It's going to do some quality analysis, right? It's going to do all the things that we would do in our pipeline to ensure quality, ultimately producing an image and putting that in a Docker Hub repository, okay? So far, so good. We want to deploy this to Kubernetes in this case, right? Now, I want to say that creating a continuous delivery demo that hits a wide swath of audience, right? That same tools, same technology, is very difficult, if not impossible to do. So if you don't use Kubernetes, don't fret, right? Try to take the principles of what's going on here. If you don't use GitHub Action, don't fret, right? Try to take the principles of what's going on here, and they do apply. But in our case, we're going to deploy to Kubernetes, okay? We want to deploy into two environments, staging and production, okay? We also then have something in our Kubernetes space called Flux System, okay? Flux is a GitOps engine, okay? And we can't dig into GitOps today just based on time, but we did a GitOps presentation maybe close to 2 years ago now, at least 18 months ago. So if you're interested in more details on GitOps, you can find that on our website for sure. But in our case, we're using Flux as a GitOps engine. GitOps is essentially going to allow us to declaratively define what we want to deploy into our environments, okay? And we're going to do that by defining it in a Git repository. And we called that here GitOps repo, okay? So we've got our application source. This is where our application code lives. We've got our GitOps source. This is where we're declaring what we want to deploy into any given environment, okay? GitOps repo, again, working on main. Flux is then configured to watch this GitOps repo, okay? It's monitoring that repo. Any declarative file or definition that lands in this GitOps repo, Flux will try to deploy it into whatever environment it's configured to go in, okay? We're going to look at this in code and kind of step through this here in a minute. So Flux, GitOps is basically saying I want to declaratively define what it is I want to deploy. Flux is going to watch it. If anything changes in this repo, it's going to deploy it, right? That gives us auditability. It gives us repeatability, right? It gives us drift detection. If something happens in our Kubernetes cluster that isn't defined in our GitOps repo, Flux can react to that and fix it for us in an automated fashion, right? So those are some of the kind of core benefits of using a GitOps approach. So far, so good. At the same time, then, Flux is monitoring our Docker Hub repository, okay, where we're putting our images. And based on policy, it's going to have the capability to update our GitOps repo on its own. Okay, so we can write policy saying if images that meet a certain criteria land in this Docker Hub repository that I'm monitoring, go ahead and tell my GitOps repo to update to those. Okay, this is really the continuous delivery piece of this, right? Flux is not only monitoring what it's supposed to have deployed at any minute, it's also monitoring what we're producing on the back end, right? And based on policy, it will automatically update our GitOps repo for us. The loop here then, right, because it's working on a control loop, Flux then says, update this. As soon as it gets updated, it goes, oh, there's new changes that I need to deploy, right? So it updates the GitOps repo. It's monitoring that same GitOps repo. When those new changes land, those new changes will land here in production and staging. Clear as mud, I can tell. I'm going to clear this up. So we're going to start with our application. Remember, up in the upper right-hand corner, we said we have an API, right? Happens to be a GraphQL API, and this is the source code for that. This isn't a GraphQL class or a training session on GraphQL. So take for granted that this runs. But the important part of this is that I've defined some schema here in my API based on a GraphQL schema, right? And if I come here, I can run this. So if I run this application, I'm going to do this just so you kind of see how it should behave, right? If I run it and I go out to what's deployed, I can now execute queries against that API, right? I just put a GraphQL playground over the top so you can kind of visualize what it's doing, right? Important point here is that if I look at my schema says you can query movie types by specific movie IDs or by what we call the now playing query, okay? But over here, you see that now playing is my query, and I can say I want ID, title, overview, and when I execute this query, I get this, right? I can modify my query. Now I'm getting poster path. Now I'm not getting overview, right? Simple GraphQL API. That's our implementation that we want to deploy. So far, so good. We want to deploy this, we said, into Kubernetes, okay? So we're going to use OpenShift in this case, mainly because it demos a little better. The administration console in OpenShift is easier to visualize what's going on. So out in OpenShift or Kubernetes, you'll see I have a staging environment. My staging environment has nothing in it, okay? I have a production environment. My production environment currently has nothing in it, okay? So I'm sitting in an empty state. I'm ready to deploy my application, okay? When I want to deploy this, what we talked about on the slides was I want to use a declarative approach to deployment, right? So, and we want to use GitOps to do it. So this is, and I should have pointed this out before, that all of these repositories I'm working with are public API or public repositories in the Keyhole GitHub account. So in the Keyhole is our organization. You can find all of this stuff there and look through it. There are READMEs that talk about how it works, how it runs, how to set it up, and how to use it, and so on. There's also one here for my GitOps repository, which I've just moved on to, right? So this is my GitOps repository. This is where I'm going to declaratively define what I want to deploy, okay? Again, we can't get into all the details, but this is based on standard Kubernetes manifest files, okay? If you know Kubernetes, then this makes sense to you. If I look at this file, it's basically defining a deployment, a Kubernetes resource type called now playing API, and it's pointed out to my Keyhole now playing Docker image, okay? Out here in our API, based on a GitHub workflow and a Docker file, we're producing a Docker image, right? So if I go over to my now playing API and I look at my GitHub Actions, my pipelines that I've run, you'll see I've had one pipeline run on this repository. It was my GitOps demo starting commit from 5 days ago, okay? If I look at this action, this workflow, you'll see that it ran some unit tests, it did some quality analysis, and then it built and pushed my image. So that's my build automation, build and test automation, right? Run the test, quality analysis, build and push. If I look at the commit, it's kind of hard to see there, probably on the screen. My commit number is 52828C2, 5282C82, right? If I look over in Docker Hub, you'll see that I have a tag here called 52288C2A or whatever it was. I said that different that time, it felt like, but you get the point that my Docker image is tagged with my commit that it was built from, okay? Doesn't have to be that way, but it does a good job of auditing and carrying things through and make, troubleshooting this easier later. And it also helps us track what's going on here for the demo. So I've got this Docker image produced over in my GitOps repo. I know a lot of switching back and forth here. So I'm saying, hey, make a deployment of that 52828C2A application image, okay? Configure some environment variables, configure a config map for my feature flags, which we're going to get to in a minute, create a load balancer over the top, and ultimately expose some ingress to my application. All of that not terribly important unless you like Kubernetes. But if I come here now, I could use an imperative approach to this and say, hey, go deploy this. And if I come out to my staging environment, we should see this pop in here. There's my now playing API being deployed, right? I've got a pod running with a container inside of it. That container is pointed to, make this bigger, 5228C2A, right? That's my image I wanted to run. So this repository declares what I want deployed. I happen to do that in an imperative way there, right? I didn't use GitOps to do that. I just manually said, go install this, which works. However, the problem with that is if I get drift in my environment or somebody else does some deployment from their local workstation that undoes something I just did, I don't have any audit trail of what's happening. I don't really know what my desired state is, right? I need this GitOps repository to be monitored by Flux, and Flux do the deployment for me versus me doing this direct apply manually in an imperative fashion. Does this make sense? So I'm going to delete what I did. We should see that go away. There's my workload gone, right? And I want to do this in an imperative fashion, okay? What we've said here is that Flux is doing the monitoring of this GitOps repo for us, okay? This window. So if I look at all the projects or all the namespaces I have available to me in Kubernetes, I only see 2 because of my role-based access. But if I log in as an admin here, it always makes me do it twice for some reason. So if I log in as an admin, you'll see that I have a bunch more stuff installed in OpenShift here. And one of those things is called Flux System, right off the diagram that I showed you up front, okay? Don't really, again, want to get into this too deeply, but the key here is that Flux is running in my Kubernetes cluster. Flux is monitoring through my configuration. It's monitoring my GitOps repo. So if anything lands in that GitOps repo, it's going to try to deploy it for me, just like I did it with that OC apply command, right? It'll do it for me. It's monitoring Helm. It's monitoring Customize. It's monitoring straight Kubernetes source, right? It has the capability of monitoring all kinds of things and doing deployments for me. I'll log back in here as myself. There we go. And this should be production. So one more. Home project staging. So in staging, I have nothing. In production, I have nothing, okay? If I go back over to my GitOps repo, you see I have 3 changes here that I haven't committed. So my current state that's sitting in that branch, it's everything commented out here. That's why nothing is deployed, right? Flux is looking at it. It's monitoring this GitOps repo, but everything's commented out. So I'm going to make a commit that's going to basically say install these things, right? If I go look at those things, basically I'm saying go install this now playing deployment, which includes a secret, a deployment, a service, and a route. Install my feature flags and do it in each environment. Do it in a production environment, do it in a staging environment, okay? I'm going to take this moment to say, because I realized that some of this for you, you need a lot more detail, right? So I should have said this up front, but if if anybody on the call wants more in-depth discussion on this at any point, please reach out to us. Okay, we'd love to talk about this in more detail and help unpack it more. Just trying to give you a taste of what we're doing. So at this point, if I make a commit in this repository, what's going to happen is Flux is going to monitor that commit. It's going to recognize that it's there, and it's going to do that deployment for me. And we can kind of witness this through what I'm looking at here. Basically, I'm saying, hey, Flux, show me what you're doing with this repository at this moment. And currently it's saying, hey, I've applied 981727 as a commit, okay? If I look over here at my last commit, it's 981727, okay? So Flux is watching that repository, and it's deployed 981727 with my commented out code, right? If I uncomment that and sync it, Flux is going to recognize that there was a change there, and it's going to deploy that for me. So the principle here is that anything that I change in that GitOps repository, Flux is going to try to do something with, right? That's my automated deployment, and it's running on a 1-minute cycle, I think, currently. So hopefully I didn't catch it at 59 seconds, and we have to sit here for a long time. There it goes. So it's deploying staging. If I can get over there fast enough. Here's my staging container popping up. Here's my container running, just like when I deployed it by hand, right? If I look at that container is running my 528C2A container or image that I built, right? Probably I go back now, you'll see that it's deployed production as well, okay? So all deployments are happening declaratively through a git commit, right? Very, very powerful. A little mind-blowing, a little like, how the heck can I get this to work? But very, very powerful and really not as complicated as I think I just made it sound, I promise. Okay. So now we've got these things deployed, right? So if I come out here and I'm going to make this a little bit, is that too small? It's just hard for me to work when it's that. If I'm sitting in my staging environment and I go hit that app now, right? Here's my now playing staging URL. I'm no longer running on local. And if I do my query, I don't have syntax error, I should get the same things, right? So my API is now out there running in my staging environment, working fine. Same thing, if I come to my production environment, it's running fine, right? Here's my production URL. So I've successfully deployed this now to my staging and my production environment, okay? All of that now leads up to our continuous delivery piece, right? Took a little setup here. The idea here is, though, let's say that user comes to us and say, hey, I know I can get, let's just actually go back out here. I know in the schema you're giving me movie info, but what if I want to know what actors are in the movie, right? What cast is in the movie, or what crew, what, who's producing the movie, and so on. I want you to add that as a feature, okay? So the principle here is I should be able to go add that feature, commit it on my once per day cycle, like we talked about in the continuous delivery demo, and then deploy it to environments in any fashion I want, okay? And protect it with a feature flag in case I want to turn it off and on in that moment, okay? So we're going to come back to our now playing API. We look at our source code here, and I promise I'm not going to do a bunch of coding in front of me. I'm just going to merge in a branch that I have set up. But if I look at my source, you'll see before I do any changes here, my current source just defines a movie type and a couple queries, right? If I come here and merge in some change code, git merge, there we go. If I merge in my changes, let's say I just sat here and developed for the last 30 minutes, right? Now I've got my changes. You'll see that now I have a movie that adds a credits to my schema, right? And credits gives me cast and crew. And cast is a name and a character, and crew is a name and a job they're performing on my movie, right? So I've essentially now added behavior to my API, right? Just like I would for any development I want to do. And I've protected my application with or this new feature with a feature flag, basically saying if my feature flag is enabled, credits is enabled, then I'm going to merge in this new credit type. If it's not enabled, I'm not going to merge it in, right? If I run this now, sorry about that. If I run it locally, just like I did before, this will be my normal testing process, right? I should see that now I can query on credits, basically adding the behavior to my app. So if I come back out here like I did before, if I look at my schema now, notice my schema has credits in it, right? Has new types. And if I come here, I can do the same old queries I did before, or I can say, hey, show me some credit information. I want cast, I want name, and I want character, right? So every now movie, I'm saying well, my cast is Chris Hemsworth is Thor, Christian Bale is Gore. Great movie. I don't know if anybody saw it recently. Tessa Thompson is King Valkyrie, right? So all of my cast information is available now. If I do the same thing here, and I should show you this, my feature flag implementation is really at this point just based on environment variables, right? So very simple approach. If credits enabled is in my environment is on, then I'm going to enable my feature flag, right? If I come down here and look at my environment, you'll see credits enabled is true, right? If I export that as false and I rerun this, it's ready, and go back over here, you'll see now that it went away, right? So my code, that's a feature flag, right? My code paths are protected by whether I want to turn those features on or off. Notice that as soon as I did that, the screen updated and said, hey, the credits are no longer available. If I try to query that, I get an error, right? Because it's not part of my feature set anymore. And it's not published as part of my API, right? If I do my normal query, it still works, okay? So essentially, I've introduced code into my code base through a feature flag that I can turn on and off, okay? So obvious next step then is I want to deploy this, okay? How do we do that? Anybody want to answer that? We do it through our GitOps declarative process, right? So out here, I'm saying I want to deploy my API. My GitOps engine Flux is already monitoring this and already deploying this. So to get it to deploy something new, all I really have to do is produce a new Docker image, right? We go back to our demo slide. There we go, slideshow. Right? If we go back here, we said that Flux is not only monitoring this GitOps repo, it's also monitoring Docker Hub, right? And by policy, when new things land here, it will update our GitOps repo for us, thus causing a deployment to happen in an automated fashion, okay? So that's what we're going to see here. Is essentially I want to go to my now playing API, window, now playing API, and I want to commit this code. Okay, here's my changes. I'm going to just make this easier to read. I'm going to say added credit feature. Okay, I'm going to commit this, and then I'm going to push. Now, this is where it's going to get a little bit hard to follow, I think. Way harder than it's already been, right? So when I commit this, it's going to kick off an automated pipeline. That automated pipeline is the same pipeline we looked at before, right? So if I come out here to my GitHub Actions, we're going to see a pipeline start to flow here immediately. Everything else from my commit push that I'm doing manually is going to happen automatically, okay? We're going to see the pipeline run. It's going to run our tests, going to run our quality analysis. It's going to push that image to the repository. Then we're going to see Flux pick that change up here, right? We should see a change happen. Actually, we probably won't see it here. We'll see it happen because it's an image policy. So if I do Flux watch image policy, right? This is Flux monitoring my image repository, basically saying, here's what I found. And we'll see right now, you see it found 5282C828, right? That's the current image I've said to deploy. So we're going to push the button to commit this change up to our repo. It's going to kick off the pipeline. The pipeline is going to deploy the image. Flux is going to recognize that image is there. It's going to update our GitOps repo, and then it's going to get deployed because our GitOps repo got updated. There's mud. All right. Let's see if it works. Wouldn't it be funny if it didn't work after all that? Push back over here. All right, so here's my production image. Here's my staging image. If we go look at this GitHub Action, it's out here running, okay? Right now it's running my unit tests. Okay. Then it's going to do some quality analysis. Then it's going to build and push that image. Once we see it push that image, we should see that image get recognized as a change. What's currently running out here while we got that running is a container with 5282C28. That's our old original image with no credit feature in it. Okay. We'll stop right there. We should see that redeploy in a second. It's pushing the image. This takes about 50 seconds or so. I got 40 seconds. While that's running, let's go look at this, and I'll just show you something here that I wanted to get to in a minute anyway. So if I look at my tests, and this is an important concept. If I look at the tests I ran on my original pipeline when I didn't have a credits feature, right? My test said, I did two tests essentially, my now playing with base properties and my movie ID with base properties, right? That's my test that I did, my automated test that I performed during my pipeline, okay? If I go look here at the new one, this shouldn't be surprising, just showing you that it's possible. Now you'll see that I have a credit test in there. So the kind of the key principle is there, even though I may not turn features on and off, I need to have tests so that if they get turned on, they're getting tests, right? So that's being handled by my pipeline. So now I'm testing three things. I go back. It's pushed. If I go back out here to my Docker Hub repository, I might miss all this because I was messing around there. Go to now playing API. Now we should see a new tag, F7AE9, right? If I go back out here to my GitOps Flux, it hasn't updated yet. That's good. So we made it before we got there. What's that? Oh, yeah, the bottom one did, F7AE9. Now, if I can make it back over here real quick, we should see this redeploy here in a second. Oop, got a cap on my water. So I know I talked through a lot of parts and pieces here, but this is about as automated as we could make this, right? I committed code. I ran all my unit tests, ran my quality analysis. It produced an image. Flux looked at that image, updated my GitOps repo. My GitOps repo caused a redeployment, right? Everything post my commit is automated. This is really continuous deployment, not just continuous delivery, right? It's continuous deployment. I could do this same model with continuous delivery and say, I'm only going to deploy to my staging environment, and I have some other process that I go to actually push it to production. Could work the same way. There's my staging container going. Should probably see the same thing over here if I didn't miss it already. That's production. Was I on production over here as well? Nope, staging. Regardless, trust me, it's going to work. Don't need to sit there and wait for it. So now if I go out here to my playground on staging, okay, do my query works. If I look at my schema, I have no credits, okay? If I look at my topology here and what I actually deployed, down here, I did deploy my new F7AE9. So what gives? Feature flags are defaulted off, right? So again, feature flags default to off. So to change my feature flags in any given environment, I'm going to use my GitOps repo, okay? Any changes I want to make to my environment, I'm going to do declaratively. So I'm going to come here to my environment file, and I'm going to say credits enabled equals, spell it right, that'll probably work better, enabled, is that right? Looks like enabled to me suddenly. True, right? I'm gonna go ahead and turn it on production too, so we only have to do this once. Production, true. So again, I'm controlling each environment independently, right? I could do this feature flag in a lot of different ways. I just happen to be using environment variables for this, but now my changes are adding credits enabled to true to production, adding credits enabled true to staging, commit, added credits, let's just say enabled. Oops, spelled it wrong, feature. All right. I'm going to push this up. I'm going to show you one thing I forgot to show you there. See, I had two incoming, look at that down at the bottom, went away. I had two incoming changes, right? Well, I didn't change that, right? Flux updated that for me. So I want to walk through that as at the last here in a second. Where do I have a contact on my page? So now if I come out here, let's go back to our GitOps repository. Look at this, watch. It's updating staging with 6BC. That was my last commit, I'm hoping. Enable credits feature. No, it's D85. D enabled credits feature. Oh, yes, this is okay. This is okay. So if I come back over here now, I should see projects, staging, workloads, D875. That's what I'm after. Oh, I did a merge branch. That's why. Okay. I didn't squash my merge, so I had a merge branch in there. So that's FO1E should be deployed. So if I come back out here now, I look at this, and my container updated just now. I bet if I go back to my playground and I refresh, now I have credits in staging, right? Thought I really blew it there for a second. Credits, cast, name, character, right? And now I can do credits here. Same thing in production. That's a lot, okay? I mentioned, and it's probably easier to show you this in GitHub, and this really speaks to this process here again, if we go back here. Flux is monitoring my Docker Hub repository. Any changes that land here, it's writing back to my GitOps repo for me. All right, so I've given it policy, I've given it permission, I've given it configuration to update my GitOps repository under certain policies, right? So what that means is if I go back over here and I look at my GitHub or my GitOps repo and I look at my commits, I had commits done by Flux CD bot. Here's where I enabled the credits feature, right? But Flux updated that image for me, right? If I go back to my GitOps repository, this is very important. This is subtle, but it's very important. If I go back and actually look at my source code, and I look at my customization and staging, notice my new tag is F7AE9E5C, okay? And if I look at my git blame over here, that was done by Flux CDBot 6 minutes ago, okay? It's a subtle little thing, but it's important that any changes that are being made by me or by external systems, they're declarative, right? If I were to tear down this Kubernetes cluster and rebuild it from scratch, I could deploy the exact same thing again because it's declared here, right? Flux didn't just take that image and update it without updating my declarative definition of what I wanted. Does that make sense? Okay. I think that's it. I know that's a lot. Hopefully, again, this is very specific to Kubernetes and GitOps, which is what we advertise. So hopefully that was useful to some folks. But if not, if that's not your world, I think the principles that we talked through still apply. Okay, we really do appreciate, as we said, you joining today. Again, there's a lot here in terms of the implementation, really hard to walk through in any kind of light way. So if you have any interest, if this is your world, Kubernetes, GitOps, you're interested in that space, and you want to go into more depth with us, please reach out for sure. We thank you very much.